to Pomodoro Joe for Saturday, January 14th, 2023. Today we'll be looking at LeetCode problem 1061, lexicographically smallest equivalent string. This is a medium problem. And the problem statement says you are given two strings of the same length, S1 and S2, and a string, base string. We say S1 at index I and S2 index I are equivalent characters. For example, if S1 is ABC and S2 is CDE, then A is equivalent to C, B is equivalent to D, and C is equivalent to E. So this is just saying that characters at the same positions in S1 and S2 are considered equivalent. So the first characters, A and C, are equivalent, second characters, B and D, are equivalent, and so on and so forth. Equivalent characters follow the usual rules of any equivalence relation. So reflexivity, that's A is equal to A. Symmetry, if A is equal to B, that implies that B is equal to A. And transitivity, if A is equal to B and B is equal to C, then A is equal to C. Has an example, and then it says, your goal is to return the lexicographically smallest, that means letters earlier in the alphabet, so lexicographically smallest equivalent string of the base string by using the equivalency information from S1 and S2. So this is just saying we're given some set of characters, S1 and S2, that have equivalent groups. You want to find the smallest letter in each group, and for every character in the base string, replace its character with the smallest equivalent character, and then return the result. So let's get started. We'll put 25 minutes on our Pomodoro timer, and here we go. We'll start with some result. We'll make it an empty string, and at some point we'll return that result after we are done building it up. Now what do we need to do? We need to build our groups. So step one, we'll create our groups. So for each index in our range of length S1, we will have some character at that index. So C1 is equal to S1 at index I, and we'll have a character in string 2, so C2 is equal to S2 at index I. And then we'll group these together. So we'll just have some function like add to group, or I'll just call it group. So we will group these C1 and C2 together. And we don't have this function yet, so let's put some placeholder in up here. So def group, we'll take in character A and character B, and we'll do something, put them into some kind of group structure. And then once we have our groups, we have to build our result. So for every character in our base string, we need to append the equivalent character. So we'll say find the group for that string and append that group, well, equivalent character for that group into the result. So this find group is another function we don't have yet, so let's create that up here. So def find group, and it's just going to take in one character and it will return one character. Okay, so we are defining our groups based on this. We're basically saying our group can be defined by the one character that is the smallest character, lexicographically smallest character in that group. So every group has a set of characters, but it only has one character that identifies that group, and that one character is the smallest character in the group. So how do we do that? Well, that's where something called a union find comes in. So this is essentially a union find algorithm. You can look it up, but I will try to describe it here. So in our group, we'll basically say, okay, we have some group for each of these characters. So group A is going to be, well, what? Oh, we can find it because we have this function, find group. So we'll find the group for group A. And group B will be find group for character B. Okay, so this is just telling us group A and group B, these are going to hold one character that represents the smallest character, lexicographically smallest character in that group. So if group A is the smallest one, So because we're grouping these two together, we had some new character A, new character B. If group A is smaller than group B, that means that we can actually say these groups are merging, and we'll identify them now by group A because that is the smaller character. So we can replace our group B's identifier with A. Now we don't actually have any grouping structure yet. So how do we want to store our groups? So we need some data structure to store our groups. Well, what do we need? So we need to have, let's see, some character map. So it's going to take in some character, and it's going to have to map to some other character. So this is going to be our smallest character for that group. This seems like a dictionary to me. So the dictionary is going to be, let's see, our key will be some character. So the character we're looking for, and the value will be the smallest character in that group. Okay, so if we have some groups, then we could say groups with this group B. So going back to what we had here, we're saying let's find the group for character A, find the group for character B, and then if character A's group identifier is smaller than character B's group identifier, then we can actually replace the character B's group identifier with group A's group identifier. That's a lot to say, but essentially you're saying we have two groups, A and B. They're identified by some character. We're merging them together. Now we want to find the smaller of the two characters that identify these two groups, and that new character, or that character, will identify this new combined group of both A and B. So if group A was smaller, then group A now becomes the identifier for our groups. If group B is smaller, then group B becomes the identifier for both groups. Okay, so that handles our grouping. Now we have to go to our finding. How do we find these characters? Okay, well, let's see if the character is even in the dictionary. If C is not in our groups, we don't actually have a group yet. Well, then let's create some group for our C. And what do we set it to? Well, this is the only character in this group. So this whole group is identified by this character. All right. And what if we do have this character? So if C is in our group, so if our group's at C, so if groups at C is just equal to our current character, that means that this is what we would call the root of the group. Basically, this character is the smallest character in the group because it's not only in the group, but it's also the identifier for the group. Well, at that point, we can just return this group. We can say, yeah, we found the right group. So find group is going to return the group for this character. And if it's not, however, so if group C is not the root, that means we need to keep looking. So we have some, how do I put this? So we'll have the group root, and that's going to be equal to groups at C. So this is like the group identifier. Maybe I'll call it group identifier instead of group root. So this group identifier is the thing in our dictionary. So if this group identifier, maybe I'll put this up here, make it a little bit clearer. So we have some group identifier. Now if this group identifier is the character that we passed in, that means that this character is the smallest character in the group, and we just return that character. If this is not the smallest character in the group, then we want to keep going. We want to find the smallest character. So then we can say, well, let's see, actually our group identifier is not the value in the dictionary for this character. It's going to be whatever we can find for that group identifier's root. So we keep recursing to find the smallest group identifier, and then we can finally return that group identifier. So we have a little bit of time before we run this. Actually, we're running low on time. So this actually should handle everything. We have a way of grouping characters together. We have a way of finding the smallest character in our particular group. And we have our replacement algorithm for replacing all the characters in the base string with the smallest character in that group. Let's give this a shot and see if this works. Hey, that works. Let's submit this and see if we pass all the other tests. And we do. Not bad. And this has a pretty decent runtime. It beats 98% of other submissions in runtime. It only beats 22% in terms of memory. We could probably make some improvements on that. Let's jump back to the description and see what we can do. So one thing we can do is I'm using these sort of temporary variables, group A and group B. We might be able to get away with not doing that by just embedding these finds in our algorithm here. I'm also using this group identifier. We could replace that with this group C, any place we see group identifier. I'm also breaking out C1 and C2 when we could replace those here. So there are things that we can do to improve our memory footprint. I don't know if it's really worth it. I think what's more worth your time is looking into the union find algorithm and how it works. So, all right. Hope you enjoyed this one. Hope you had fun. Hope you learned something. Check out the union find algorithm. It's pretty interesting. And write better code.